Hello, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is the first video in the lesson on inclined planes, and I'm just going to be introducing the concept and talking about the forces that act on a system such as this. Okay, so here we have an object, a mass, that is on an inclined plane, and it's inclined at theta degrees to the horizontal. And we're just going to start by thinking about what forces are acting on this particle. So first force that we're going to consider is its weight. Now the weight will act straight down vertically and will have magnitude value mass times gravity mg. Now the normal reaction force, which all the horizontal problems we've done will be acting vertically, that normal reaction force is now going to be acting perpendicular to the units get involved today. Now, another force that might be acting on this system is we might have a friction force acting up the plane because the box is going to be inclined to want to slide down the plane. And the force, the weight component of the force going down the plane might be enough to overcome friction and cause the box to move. But what we need to do is we need to decide what is the magnitude of that weight component down the slope. And the way we're going to do that is to resolve this weight into components which are parallel to the slope and perpendicular to the slope. So I'm just going to draw that in as dashed component lines. So I've got this force here, which is its weight component perpendicular to the slope, and this force here, which is its weight component parallel to the slope. Now, this angle here is going to be equal to theta, which is the angle at which the plane is inclined. And what that means is that this force here, which is adjacent to the angle, is going to be mg cos theta, so mass times gravity times cos the angle. And this force here is going to be mg sine theta. So whenever we're doing questions where we have a particle on an inclined plane, what we're always going to have to do is to resolve the weight into its components perpendicular to the slope and parallel to the slope. It's always going to be mass times gravity times cos theta perpendicular, and it's always going to be mass times gravity times sine theta parallel. And I'll give you a massive hint right now, that is the one that everyone always forgets. Okay? Join me in the next video where we'll do a numerical example and put all this into practice. I'll see you then.